Okay, so now thank you very much for joining. So precision and accuracy. So these are terms which we often hear, especially when we talk about quantitative analysis or quantitative measurements. So then what exactly do these terms mean? And it's very, very important to be able to understand them. So accuracy refers to the agreement of a particular value with a true value. So basically, how you want to look at this is when you are talking about accuracy, you have the true value. So what's the true value? For instance, if we are trying to assess the mass of a particular copper ore, and then it's already been measured by a very, very accurate equipment. So then we're taking that value that has been found to be what, to be the true value, and then you then give the same sample to different students, and then each particular student is going to have what, different values. Then you are now comparing each value that a student has found, and then you are relating that particular value to the true value that was found by a very, very high, specific and precise. Okay, or for now let's avoid using precise, but let's just say with an equipment which is very, very accurate. Okay, and we know that we've now gotten our true value. So now what you'll be doing is that you look at that particular value that you are comparing, and then you are saying how close is it to the true value that you found. And so you are basically comparing each particular value that a student has given with a true value, or each value that has been found in the lab with a true value. Okay, so that's basically how, and this would make sense when you go to a lab and your demonstrator or your tutor may have already done the titration and already has got the answers, and then wants you to do the same procedure, and then he or she will be comparing what, your answers to the answers that he or she found. So he's trying to compare the accuracy, looks at your answer, looks at his answer, and says, okay, how close is this answer, is it in what degree of agreement does this particular value have with a true value? So that's about accuracy. Then when we talk about precision, precision always talks about agreement among several measures of the same quantity. So here you're not comparing with regards to the true value. Here you are looking at the different measurements that have been made by a particular group, or by a particular individual. So let's say that same copper ore example that I gave, let's say you are made to do to make 10 measurements, right? And then with precision, what you are looking at is how close are those values that you found to one another, how close are they with one another. Okay, what degree of agreement are they between them? Are they too different? Is the different, are the differences too high? All those things, right? So you are comparing the degree of agreement among several measurements of the same quantity. So basically with precision is you found a certain value, and then you're just asking how how reproducible is this particular value. If I found 0.2 kg, am I going to find the same 0.2 kg, or maybe I'm going to find something so much higher or so much lower? So that's basically what precision talks about. So there's this lovely picture here that will just help us understand this. So when we go to the first part, the one that's on the far left, you see it's neither precise nor accurate. So how are we understanding this, or why are we saying that it's neither accurate nor precise? Because remember, accuracy, we are talking about hitting the bullseye, isn't it? And when you see all those darts, none of them has what, none of them has hit the bullseye, or none of them is close to the bullseye. So you are saying, okay, it's not accurate. Now let's talk about precision. What's precision? The different values. Okay, so we are considering the darts as being values, okay, from a certain experiment, right? So now you're saying how close are those dots together? You see that they are not very close. And the points to which they are pointing, they are not very close. So you see that even the precision is it's bad. Okay, it's not precise. Then when we go to the second one, the B, which is in the middle, you see that these darts have missed the bullseye, but one thing about them is that they are close together, so they are in agreement, isn't it? They are in agreement. So even though they are not accurate, but they are definitely precise. Then when you look at C, which is on the far right, you see that they are close to the bullseye and then they are close together. So they are both accurate and what precise. Huh? Now, before we can wind up on this, we then want to talk about two types of errors. So there's what we call the random error, also called an indeterminate error. So basically, what you are looking at in the so this means a measurement has an equal probability of being high and low, or high or low. So what this basically means is that when you look at that particular example that we are looking at when we're talking about uncertainty and all that, so this is an error that occurs during the experiment. Maybe someone makes a mistake in reading the volume, so you get a value which can either be lower than it should be, lower than the true value, or higher than the true value. So that's about it. Then we now talk about the systematic or determinate error. Now this is where the error occurs in the same direction each time. So this means it can either be high or always low. So what this basically means is, if you are and this usually occurs when it's actually the procedure that has got a problem. So it means that if someone has got a procedure which is which is not okay, so it entails that their values will either all be high or they'll all be low. So it's a systematic error. So that's something that's very, very important to take note of. So then how do we deal with these things? Because we know that uh, precision, accuracy are very, very important. So then in quantitative work, precision is often used as an indication of accuracy. So what this basically means is that that's why we usually want to we assume that the average of a series of precise measurements, okay, which should average out the random errors because of their equal probability of being high and low, is accurate or close to the true value. So what they are basically saying is, we know that for the random errors, remember, you can measure that this maybe the mass was, let's say you're trying to find the density of something, and then you find that maybe the mass, it's been measured higher than it should be, then the volume has been measured lower than it should be. So you find that those errors will be able to average out. And so how can you do this? You do this with what? Measuring the mean, or measuring the average of the what? The average of the values. Now you have to average the what? You have to average values which are precise. Okay. That's why you realize that even when you're doing a titration, usually there's what we call the first run, isn't it, or the trial. That one, it's not even used in calculations. Why? It's usually not precise. It's not going to be close to the others, so it can just introduce errors in your working, isn't it? So that's why when you're doing the average in a titration, you don't use the first run, because usually it's not going to be precise. So then what you see here is that someone did the working, and then they were able to come up with the average, and then that's their value. So if the balance has a defect causing it to give a result that is consistently too high, let's say by 1 gram, then the measured value of 2.486 grams, the one that we found, would be seriously in error. So the point here is that high precision among several measurements is an indication of accuracy only if systematic errors are absent. So that's something that's important to take note of. So I've basically explained that from the titration examples that I gave. Okay, so that's basically how one